GoLang maps tutorial from the golangbot.com. What is a map? A map is a built-in type in Go that is used to store key-value pairs. We know this from other computer languages. This is a very basic type. Take the example of a startup with a few employees. Each employee, let's assume that the first name of all these employees is unique. We are looking for a data structure to store the salary of each employee. A map will be a perfect fit for this use case. The name of the employee can be the key and the salary can be the value. Maps are similar to dictionaries in other languages such as Python. So how do we create a map in GoLang? A map can be created by passing the type of key and values to the make function. So we know that the creators of GoLang have come from C, and we see the reuse of the make keyword and concept. The following is the syntax to create a new map. Make map. I want to make a map, and here in square brackets the type of the key, and here the type of the value. So the type of the value is not in the square brackets. So we have like a map, type of the key, type of the value, and there is this notation with square brackets only for the key. It's a little bit weird, I have to say, but this is the syntax and it's simple once we get used to it. Okay, you see, this looks simple, we have to admit. Example, employee salary, make, map, string, int. So we are creating here a map from the key of type string to the value of type int. The above line of code creates a map named employee salary, which has string keys and int values. Let's see this in an actual code example. We have here employee salary, make map, string int, and then we print the employee salary map. The program creates a map named employee salary with string, key, and int value. The above program will print an empty map. Since we have not added any elements yet to the map, it's empty. This goes with all the concepts of GoLang, which is without nils and creating default empty for items. This is why when we check in GoLang if a string is null, we don't check if it's null, we check if it's empty. Adding items to a map. The syntax for adding new items to a map is the same as that of arrays. The program below adds some new employees to the employee salary map. So first we have employee salary is make map string int, and then we add a couple of items with square brackets. Employee salary Steve is 12,000, and so on. When we print it, we get the map context in some string notation. This is not JSON, just the object. But it's nice that we can pass to fmt println a map and just print it, and not the reference to the object in memory. It's also possible to initialize a map during declaration itself. Similarly to Java, we use the curly braces and then key value in order to initialize a map on creation. It's not necessary that only string types should be keys, of course. All comparable types such as Boolean, integer, float, complex, strings can be keys. Even user-defined types such as structs can be keys. If you would like to know more, then there is another blog post. Actually, the comparison operators in GoLang.org. zero values of map. The zero of value of map is nil. So this is similar to linear algebra where we have the zero value. And I guesstimate that it would support operators like in linear algebra, the zero value. If you try to add elements to a nil map, a runtime panic will occur. Hence, the map has to be initialized before adding elements. Yeah. So here we did not call make map, and because we did not call the make function to create a map, we just set a variable to a map, we cannot assign values to this and we'll get panic assignment to entry in nil map. Retrieving a value for a key from a map. Note that we have added some elements to the map. Let's learn how to retrieve them. Map key in square brackets is the syntax to retrieve elements from the map. So we see we have a map, we initialized it in order to get a value. The code is very clean. Go is clean. We cannot say that Go is not. Go is clean. Employee salary, square brackets, and employee. The above program is pretty straightforward. The salary of the employee is retrieved and printed. The program prints salary of Jamie is 15,000. What will happen if the element is not present? The map will return the zero value of the type of that element. In the case of employee salary map, if we try to access an element which is not present, the zero value of int, which is 0, will be returned. So you see it would not return a null when an element does not exist. It will return the zero value for int. Need to be aware of this. So the above program returns the salary of Joe as 0. There will be no runtime error when we try to retrieve, super important, the key. There will be no runtime error when we try to retrieve the value for a key that is not present in the map. Checking if a key exists. In the above section, we learned that when a key is not present, the zero value of the type will be returned. This doesn't help when we want to find out whether a key actually exists in the map. For example, we want to know whether a key is present in the employee salary map. So we have here two values, value and the second parameter's map key. The above is the syntax to find out whether a particular key is present in the map. If OK is true, the second return type from the map key, then the key is present and its value is present in the variable value, as the key is not present in the map. So we need to explicitly check the second return type when calling a map to know whether it exists in the map or not. Iterate over all elements in a map. The range form of the for loop is used to iterate over all elements of a map. So we use for key, value, range, employee salary. One important fact is that the order of the retrieval of values from a map, this is something that GoLang people are very proud of. One important fact is that the order of the retrieval of values from a map when using for range is not guaranteed to be the same for each execution of the program. It is also not the same as the order in which the elements were added to the map. I would trust them to even go, they didn't do this, to even introduce a random. So you can never expect a certain order from iterating a map. Deleting items from a map. Delete map key is the syntax to delete key from a map. The delete function does not return any value. So we actually call a function, a built-in function delete, to delete a value from a map. If we try to delete a key that is not present in map, there will be no runtime error. Yeah, because we can expect that something will not be present in a map. Map of structs. So far, we have only been storing the salary of the employee in the map. Wouldn't it be nice if we are able to store the country of each employee in the map too? This can be achieved by using a map of structs. The employee can be represented as a struct containing field salary and country, and they will be stored in the map with a string key and struct value. Let's write a program to understand how this can be done. So we create a struct of employee with both salary int and country string. And then when we create a map, we define here a variable and then initialize it. In the variable, it's from a string, the key of the map. The type of the key is string. The type of the value is employee struct. So employee struct contains field salary and country. We created 3 employees, employee 1, 2, and 3. We initialize a map with key type string and the value type employee with the 3 employees created. The map is iterated and the employee details are printed in the next line. So we just print them. The length of the map. Length of map can be determined with the len function. So we just use the len function, just like previously we used the delete function, and we ask what is the length of this map. It's just a function like in Python. Len employee salary in the example returns the length of the map. Maps are reference types. Similar to slices, maps are reference types. When a map is assigned to a new variable, they both point to the same internal data structure. Hence, changes made in one will be reflected in another. So we have one map here, and we are assigning the first map to a new variable, and we make a change in the new variable, and then we will see that it changed the original map because there are references. So employee salary is assigned to modified variable, and then the salary of Mike is changed, and when we print it, we see that it's actually changing. Maps equality. Maps can't be compared using the equal operator. The double equal operator can only be used to check if map is nil. One way to check whether 2 maps are equal is to compare each one's individual elements one by one. The other way is using reflection. So there is no built-in way to actually compare them. I would encourage you to write a program for this and make it work. I have compiled the concepts as discussed as a single program. This brings us to the end of this tutorial. Hope you enjoyed it. Please leave your comments. So this was another great tutorial by Naveen Ramantan, who is a software engineer with interested in Go, Kubernetes, Swift, Python, and WebAssembly. You can contact him by contacting him.